What does the double helix structure of DNA, Perpetration H, and Pope Pius XII all have in common? Give up? Well, the answer is the Dominican religious and PhD chemist Sister Miriam Michael Stimson, whose spectroscopic work played a major role in confirming the double helix structure of DNA, a breakthrough that many consider the most important scientific discovery of the 20th century. Hi, I'm Father Doug McGonagle. I'm a Roman Catholic priest who also happens to be a radio astronomer. If you find my musings interesting, or perhaps even thought-provoking, please hit the like button and subscribe. You might even want to click the notification bell too. I'm a full-time pastor who has to squeeze the making of these little video indiscretions into my busy schedule, and so their posting will be catch as catch can. Thank you. Born in the city of Chicago, Illinois on Christmas Eve 1913, Marion Emma Stimson was the third of 5 children born to Mary and Frank Stimson. Marion grew up primarily in Toledo, Ohio. Mary and Frank passed their Roman Catholic faith on to their children. Marion attended their parish's elementary school and Toledo's Central Catholic High School. She was a straight-A student. Miriam enjoyed school. Sister Miriam would credit her 8th grade science teacher, Sister Agatha, with igniting her interest in science. Sister Agatha was a young Franciscan sister who was herself fresh out of college. Years later, Sister Miriam would tell her biographer, Jun Tzu-chi, how Sister Agatha, quote, inspired me with a desire to know more about God through investigation of the natural wonders of creation. In an age when childhood diseases took their toll, the Stimsons were not exempt. One of Marion's older brothers suffered polio not just once, but twice. Her younger sister, Alice Ruth, contracted rheumatic fever, which left her with significant and permanent heart damage. Alice Ruth's heart condition was so debilitating that her parents decided it best for her to attend a boarding school for women, where she could receive a Catholic education while getting the care her heart condition required. St. Joseph's Academy for Women was located in the small city of Adrian, Michigan, and had been founded over 30 years earlier by the Adrian Dominican Sisters. It was also decided that Marion would accompany her sister as caretaker and complete her high school education at the academy. The 2 women arrived at the school in 1930. Only a year later, Alice Ruth's heart gave out, and she died. Sister Miriam told her biographer how, on the evening of her death, Alice Ruth and her classmates had been frolicking while one of the girls played a piano. She ought to ease up, Sister Miriam remembered commenting. Later that same night, Alice Ruth's roommate awoke to a gurgling sound coming from Alice Ruth's bed. Sister Miriam's biographer recalls how even 70 years later, Sister Miriam's voice choked as she relived the events of that night, telling her biographer, "I felt I had failed." Even so, Marion persevered through her grief and finished her high school studies in 1932. By then, the Adrian Dominican Sisters had opened a new women's college, located on the same campus as the academy and also named for St. Joseph. However, it soon became apparent that sharing similar names was problematic, and so in 1939, the new college was renamed Siena Heights College, in honor of St. Catherine of Siena. St. Catherine, who lived in the 14th century, was a strong laywoman. She was a mystic, devoted to Dominican spirituality, and is now recognized as a doctor of the Church. However, St. Catherine is perhaps best known for her browbeating Pope Gregory XI into finally leaving Avignon and moving the papal court back to Rome. The Adrian sisters, no doubt impressed by Marion's academic abilities, offered to apply the tuition that had already been paid for Alice Ruth toward Miriam's first year at St. Joseph's College. Marion accepted the offer and began her studies in the fall of 1932. During her time at Adrian, Marion got to observe the Dominican sisters closely. She felt the beginnings of a religious vocation. The sisters would often tell their students that should they have ever the slightest idea they might have a vocation to the religious life, they need to give it a try. And so at the start of her college sophomore year, Marion entered the congregation as a postulant. She continued on to the novitiate, receiving her habit and her religious name, Miriam Michael. Sister Miriam completed her Bachelor's of Science degree in chemistry in 1936. It was with some trepidation that Sister Miriam now awaited her first mission assignment after commencement. Happily, she received instruction to travel to Cincinnati, Ohio, and there enroll in the Masters of Science graduate program at the newly established Institutum Divi Thomae. This small research center was founded in 1935 by the Archbishop of Cincinnati, Most Reverend John T. McNichols, who was himself a Dominican friar. One reason why the Archbishop created the Institute was to push back against the notion that religion and science were incompatible, an idea that had been gaining ground since the late 1800s. The Institute was unique in how its students were taught. Instead of the formal lectures and classroom work of typical modern graduate programs, the Institute instead modeled itself after medieval seminaries and universities. Students would form small groups around a mentor who would then give them individual instruction, while students still attended limited number of traditional classroom-style courses. Most of their education and training as researchers occurred in small groups, sitting around a table or a lab bench with the advisor presiding. In this way, each student could specialize in whatever branch of science they were investigating, while benefiting from exposure to other related branches being pursued by their fellow graduate students. Today, we might call this a multidisciplinary approach. Upon her arrival at the Institute, Sister Miriam was assigned to work in a biochemistry group led by Dr. John Robert Loughborough, and it would be under his tutelage that she first became interested in spectroscopy. Sister also worked in the laboratory with another biochemist, Dr. Elton Strauss Cook, who sparked her interest in organic compounds such as deoxyribonucleic acid, perhaps better known as DNA. The Institutum Divi Thomae scientists were coordinating their efforts on cancer research. When Sister Miriam arrived, research was focused on cell damage and cell division. It was well known that when living cells are injured, cells in their immediate vicinity that had been quiescent suddenly start dividing at a furious pace. This cell division continues until the wounded cells have been replaced. With the wound healed, the nearby cells return to their quiet state. Researchers speculated that there were wound hormones released by the damaged cells that signaled the nearby cells to start dividing. Since cancer is a condition where cells are dividing and growing in an uncontrolled manner, the potential importance of discovering and understanding the cellular factors involved in cell division provided the motivation to try and isolate these wound hormones. After years of experimental effort, the first cellular factors involved in cell division were discovered. The growth-promoting intercellular wound hormones were named bio-dynes, for the Greek words for life force. As a graduate student, one of Sister Miriam's jobs was to study bio-dynes using ultraviolet spectroscopy. In the late 1930s, ultraviolet spectroscopy was a new field, and Sister Miriam was one of its pioneering researchers. The lab techniques Sister developed and refined would spread throughout the scientific community. Sister Miriam received her Master's of Science degree from the Institutum Divi Thomae in 1939. She returned to her alma mater and joined the chemistry faculty at Siena Heights College. She would earn her PhD from the Institutum in 1948. At around the same time, Sister Miriam was completing her master's degree work. The Institute licensed the sale of a wound-healing ointment containing bio-dyne in an effort to help raise funding for their research. In his biography of Sister Miriam, Jun Tzu-chi makes this enigmatic comment about a widely held belief among Siena Heights students concerning Sister Miriam's connection with this product. Contrary to the urban myth, Miriam did not hold the patent to this ointment. However, her role in bio-dyne research will forever be remembered by the trade name of the ointment, Perpetration H. I call this comment enigmatic because I'm not catching on to what Jun Tzu-chi is hinting at. Is he mentioning that Perpetration H, that H refers to Siena Heights? I don't know. If you do have an idea, please let me know by leaving a comment below. I'm not always the brightest light bulb in God's Christmas tree, and so feel free to help clue me in. Also, while you're writing the comment, please hit the like and subscribe button. Thank you. By the late 1940s, early 1950s, chemists and biologists were consumed with understanding the DNA molecule. Scientists like Sister Miriam were confident that genetic information was encoded in DNA. What folks wanted to know was how DNA was physically structured such that information could be encoded and decoded. In 1953, James Watson and Francis Crick, based on X-ray diffraction work carried out by Rosalind Franklin and her student Raymond Gosling, proposed a double helix structure for DNA in an April 25, 1953 article published in Nature. This model envisioned DNA as a twisted ladder, with each of the ladder's rungs being constructed from a pair of nucleobases, always adenine paired with thymine, or cytosine paired with guanine. The rungs attached to the outer helical rails, which are themselves made up of repeating sugar phosphate groups. However, getting the nucleotides to stack together in a stable manner was dependent on how the hydrogen atoms were distributed in the pair of nucleobases that made up each rung. The nucleobases could come in different tautometric forms, that is, structural forms. Now, since I'm just a simple observational radio astronomer who's already way in over my head and having a hard enough time just pronouncing all these weird chemistry terms, I'll just quote the literature by stating, thymine and guanine could be in either a keto or enol form, while cytosine and adenine could be either an amino or imino form. And we'll just leave it at that. The question now became, what was the tautomeric forms for nucleobases that make up DNA? To make the double helix model work, Watson and Crick assumed that the DNA bases were amino and keto tautomers, such that each adenine-thymine pair, as well as each cytosine and guanine pair, would be bound together by hydrogen bonds. And here is where Sister Miriam makes her major contribution by applying the newly available technology of infrared spectroscopy to the question. Early in her career, she had worked on tautomeric question by studying the effects of pH on the structure of molecules as inferred from their ultraviolet spectrum. In the end, though, her interpretation of the data was shown to be erroneous. Chastened but undaunted, she was quick to realize that the newly emerging field of infrared spectroscopy might be able to answer the tautomeric question. In many ways, infrared spectroscopy was better suited for the study of biochemical compounds than ultraviolet spectroscopy. And as luck would have it, Siena Heights College received a grant in 1948 to purchase one of the first all-electronic infrared spectrometers, a Beckman model IR2. But, and you just knew there was a but coming, there was a major problem plaguing researchers trying to use infrared spectroscopy, namely, the typical methods of preparing samples for study, such as dissolving samples in a solvent or suspending of solid samples in oil, were problematic. Among other issues, the solvents and oils would absorb infrared light and so obscure the absorption spectrum of the sample under study. There's also the problem that some biologically interesting molecules simply do not dissolve in solvents used in infrared spectroscopy. And so, many researchers were working hard to develop techniques that could overcome these limitations. In 1948, a group of researchers at the Massachusetts Institute of Technology, that included Sister Miriam's former graduate school professor John Loughborough, proposed the possibility of obtaining infrared spectrum from thin, translucent, solid films of material. At around the same time, another one of Sister's old professors, Dr. Cook, still at the Institutum Divi Thomae, was attempting to study the infrared spectrum of solid protein samples by mixing them with potassium bromide, also known as KBr, which is a solid that is pretty transparent in the infrared. Putting these two ideas together, Sister Miriam, assisted by her former student, Sister Marie Jonas O'Donnell, conceived the idea of a compressed disc technique using KBr as an infrared transparent filler. Basically, the technique involved grinding the solid biochemical compound to be studied into a fine powder, mixing it with solid potassium bromide, and then placing the mixture into a hydraulic press and fusing it under high pressure, forming a thin, semi-transparent disc. The disc was then placed into a spectrometer, where infrared light passed through the disc and an absorption spectrum measured. Since KBr is transparent to infrared light, any observed spectrum would be that of the compound under study. By the summer of 1951, the two sisters had refined their new KBr procedure to the point where Sister Miriam presented an abstract at a symposium dedicated to molecular structure and spectroscopy held at Ohio State University. The abstract's title was "The Preparation of Samples in the Solid State for Spectroscopic Studies in the Infrared and Ultraviolet Regions." Her talk was enthusiastically received. Researchers engaged in trying to use infrared spectroscopy to understand the structure of biochemical compounds were quick to realize this method could overcome the solubility and absorption problems that had plagued their research efforts. The KBr solid disc technique was soon used to provide evidence that adenine and cytosine were in fact in the amino form, while guanine was of the keto form, which are the configurations required to make the double helix model work. The two Adrian sisters submitted a paper giving the details of their KBr method to the Journal of the American Chemical Society, where it was published in the spring of 1952 with the title, "The Infrared and Ultraviolet Absorption Spectrum of Cytosine and Isocytosine in the Solid State." Sister Miriam soon began receiving invitations to speak at various workshops, symposiums, and conferences around the world. In the fall of 1951, she was invited back home to the Institutum Divi Thomae. She then became the first woman ever invited to give the Peter C. Riley Lecture on Chemistry at the University of Notre Dame. Accompanied by her mother, Mary Stimson, Sister Miriam was soon off to speaking engagements in Europe. She spoke at the Sorbonne in Paris, becoming only the second woman after Nobel laureate Madame Marie Curie to be so honored. She traveled to England, where she saw the KBR method being used at the Chester Beatty Institute of Cancer Research, London. While visiting the Max Planck Institute in Tübingen, Germany, the researchers there were shocked to learn that their lab was much better equipped than Sister Miriam's lab. She reportedly explained to her incredulous hosts, "But we don't have the Marshall Plan in Adrian." Such was the acclaim surrounding the KBR method and its application to the study of DNA that the Holy Father, Pope Pius XII, wished to meet the religious sister who had caused all the stir. As it was summertime, the audience took place in one of the papal summer estates outside Rome in a forlorn attempt to escape the notorious heat-humidity of the city. Even so, when the audience took place, it was still hot and humid. No matter, the dress code for an audience with the Pope is always strictly formal. And so it was that all the sisters wore full habits, including cloaks, to the occasion. Unfortunately, Sister Miriam's mother had not gotten the message and chose to wear a sleeveless dress on account of the heat. This fashion faux pas sent the papal court into a fair tizzy. The situation was soon remedied, however, by Sister Miriam giving her cloak, one might presume gladly, to her mother, and in so doing, covering the offending arms. Upon her return to Adrian, Sister Miriam would publish her last research paper in 1954. She then spent the next 40-some-odd years teaching. For 9 of those years, she left Siena Heights College to care for her ailing parents and teach at Keuka College, located in the Finger Lakes region of New York State. She returned to Siena Heights around 1978 to take the position of Director of Graduate Studies, a position she held until her retirement in 1991. On June 15, 2002, Sister Miriam died. A Toledo newspaper, The Blade, wrote, "Sister Miriam Stimson, 88, a professor of chemistry at Siena Heights University and a member of the Adrian Dominican Sisters, died Saturday after suffering a stroke Thursday evening." Funeral services were held on Thursday, June 20th, in the Maria Chapel at Siena Heights University. Her body was laid to rest in the Adrian Dominican Sister Cemetery. If you're interested in reading more about Sister Miriam Stimson, then please check out my book, Holy Scientist, published by the Catholic Truth Society of London. A link to my book can be found both as a pinned comment below as well as in the video's description. I've also included a link to Dr. Jun Tzuchi's biography of Sister Miriam, The Soul of DNA. I relied heavily on his work for both my book, Holy Scientist, and this video. To keep both YouTube and the FTC happy, I do need to make a disclaimer that as an Amazon affiliate, I make a little money whenever you click on one of my sponsored links. There's no extra cost to you, but it does help me to defray some of the costs of making these video indiscretions. So thank you for any support you can throw my way. You can also learn more about the science versus religion conflict myth that motivated Archbishop McNichols to create the Institutum Divi Thomae by watching this video, The Science versus Religion Conflict Myth. But please, do so only after first hitting this video's like and subscribe buttons. Till we meet again, in all the good that you strive to do, Godspeed.